Hello everyone. In this video, I'm going to talk about endo and exothermic reaction, talking about enthalpy and how to solve problems related to this topic. First, let me define endo and exothermic reactions. If we study reaction with heat exchange, we will see two types of reaction, endo and exothermic reaction. So first, based on the terminology, it means we are going to talk about thermal energy. We are going to talk about one form of energy. That is why we call that endothermic, exothermic. Based on definition, we can basically define endothermic reaction as reactions absorb heat. They gain heat. So I'm gonna write heat here or thermal energy. Absorb heat or gain heat, we call that endothermic reactions. And for exothermic reaction, we call that if the reaction is release heat, is produced heat, or heat emits. So at that time, we call that exothermic reaction. So please remember this terminology. Absorbing heat or gaining heat, it ends us to endothermic reaction. And if we have releasing heat, producing heat, and emitting heat, it means we are going to talk about exothermic reaction. If I'm going to talk about another version of reporting endo and exothermic reaction, I may say in general we have A plus B produce C and D. So they are reactants and C and D they consider as products. I'm going to write this reaction by adding heat to the reactant side, like this one. A reacts with B and they absorb heat to produce C and D. Heat as a reactant. So it means we need to absorb heat. We need to gain heat to do this reaction. So we call this reaction endothermic reaction. Endothermic reaction. So if I write heat in the reactant side on the left side, we call this type of reaction endothermic reaction. In contrast, if we are going to write like this reaction, A and B produce C and D as well as heat. They form heat. They produce heat. So heat is released. Heat is on the right side of the reaction. So at that time, I say heat is product. So heat is produced. Producing heat, it means we have exothermic reaction. Exothermic reaction. So keep in mind, heat on the product side or right side, it means we produce it. We call that exothermic reaction. This type of writing, we call that word version, word format of reporting endo and exothermic reaction. But when we are going to work on numbers, how much heat is gained, how much it is produced. So we need to work on one parameter. This parameter or function, we call that enthalpy. So enthalpy, we are going to quantify amount of heat. So let me write amount of heat. No matter is emitted or is absorbed. So this amount of heat can be denoted by delta H. Delta H. Heat or delta H can be reported like this one. If we are going to report that one for one particular reaction, we call that delta H of reaction. So delta H enthalpy, it means we are talking about amount of heat exchanged during a reaction. Again, no matter is absorbed or is released. One thing I may ask you, when we are going to work on delta H, we need to determine our endothermic exothermic reaction. We are going to know if we have endo and exo, what specific sign should be used. Based on convention, I ask you please keep in mind this information, this assumption when we are going to solve our problem. For endothermic and exothermic reaction, we have these two basic definition. If we have positive delta H, or let me write delta H positive, we call that endo, negative delta H, we call that exo. So it's easy to memorize. In case we have endothermic, it means we have a positive number, and if we have delta H negative, we have exothermic. So let me give it you one example to understand what does that mean. If I say, for example, delta H for this react for one particular reaction is positive 108 kilojoules, it means we have endothermic reaction. And otherwise, if I say delta H of one reaction is negative 91 kilojoule, it means we have exothermic reaction. Please pay attention. I talk about kilojoules. The reason, because we talk about heat or thermal energy, and as you know that one form of energy is thermal energy. Units for energy are joules or calorie, and we can easily convert calorie to joules by using one conversion factor like this one. But in our class, we prefer to use our unit as joules. And since they are large scale, large amount of heat, we use kilojoules to report the delta H. But in case you study some other resources and you saw calorie, most likely old-fashioned textbook, so you can easily convert them to each other. So let me summarize this part. I already talked about endo and exothermic reaction. I defined endo and exothermic reaction based on the word format. And right now, in this slide, I wanted to ask you to remember positive and negative signs for these two classes of compounds. Right now, I'm going to work on a couple of examples for endothermic and exothermic reactions and remind you what does that mean, how to work on stoichiometric problems. First, let me work on this reaction. Assume that we have this reaction. Ammonia gas react with oxygen to produce nitrogen monoxide and H2O. Let me balance this reaction. You know how to balance this reaction. I'm sure you already watched my previous videos regarding how to balance the chemical reactions. So we have these coefficients. And I said, let me write that one as a gas as well. So I'm gonna say that one, delta H for this particular reaction is going to be negative 906 kilojoule. What does that mean? It means during this reaction, ammonia reacts with oxygen, produce nitrogen monoxide, water, and this amount of energy, this amount of heat. If I'm going to work on this, I'm going to remind you this number can be related by all of the coefficients here. You can say 4 moles NH3 make this amount of energy. You may say 5 moles of oxygen make this amount of energy. Or you may say 4 moles, this product may produce this amount of heat, and it would be same for 6 moles water. It depends on our problem, depends on the question. You can use one of these coefficients because of the substance and relate to the numbers. So let me work on this one. Question says calculate the heat in kilojoules if we use, for example, 155 grams NH3. So question says calculate amount of heat. So calculate amount of heat. So let me write that one. Question mark heat in kilojoules. If we use 155 grams NH3. So I'm gonna write 155 grams NH3. So you can easily solve this problem. Based on the stoichiometric problem, you learn that always we start with the given number. This original number is 155 grams NH3, and I have to rewrite this one here to cancel it out. And I need to convert grams to moles. The reason we need to do that because the numbers on the balanced equation, they are moles. So always we need to convert to moles to apply the balanced chemical equation information. The coefficients on the balanced equation, they are moles as a SI unit of quantity in the chemistry. But I am going to convert grams to moles. We call that molar mass. So always we use molar mass to convert grams to moles. So you should say easily 1 mole NH3, it would be same as 17.04 grams. So you can calculate molar mass of NH3 by using the periodic table. So grams NH3 and grams NH3 cancel out. I do have moles of NH3. So the next conversion factor, I'm gonna write it here. I should write moles NH3, and I'm gonna convert that one to kilojoules, amount of the energy. Please look here, this information is coming from the balanced reaction, So let me write it here. If you don't balance your reaction, you cannot solve your problem. So let me write the balanced equation. We already talked about this earlier. Kilojoules and moles NH3. Please look at the moles NH3 is 4, and kilojoules amount of the energy is negative 906. Let me keep negative in our calculation. I am going to explain for you a little bit later. Moles NH3 and moles NH3 cancel out. So you need to solve your problems and report your answer in the only remaining unit kilojoules. Because we have 3 suffix at the beginning, we are going to end up by 3 suffix for our final answer. So let me calculate that one and share my answer here. And I ask you to double check by your calculator to make sure you have the same number like me. So divided by these numbers. So I'm gonna get this number. 2060 is the correct answer. It has 3 suffix because we don't count the 0 at the end as suffix. It has 3 suffix. You may report that one as scientific notation. But please pay attention. I'm going to talk about this number. We have a negative sign here. So when you calculate that, you have a negative sign here. What does that mean, this negative sign? This negative sign, it means during this reaction, we have 2060 kilojoule which produced, which released, which emit from this reaction. So the negative can be interpreted, can be explained like this form. Negative, it means delta H is representing we have exothermic reaction, and this amount of energy is produced. And finally, I'm gonna have a quick review regarding the types of reaction. For combustion reaction, we already knew that they are exothermic reaction. So we can easily say for them delta H of combustion reaction are negative. So please keep it in mind. And for decomposition reaction, when we start with only one reactant, so we do have most likely in general endothermic reaction. So we may say delta H positive. As you know that chemistry is a practical science, so we may have exceptions. But in general, when we are going to solve our problems, we can consider like these definitions as well. So to finalize this part, we are going to study heat, thermal energy, and also the reaction. We may have a variety of the questions for stoichiometric problems. You just need to set up the strategy that you learn that one. You may have the heat as a given information and you need to calculate mass. So you can easily solve that one. Let me solve one of the problems that I'm interested to work on related to this part. Assume that we have this reaction. So assume that we have this reaction. Nitrogen gas plus oxygen gas make NO gas, nitrogen monoxide. And let me balance that one as 2 nitrogen monoxide. Delta H for this particular reaction is positive 18. Let me write 183 kilojoule. 183 kilojoules. So question says, how many grams of nitrogen should be used to absorb 2.91 kilojoules. So let me work on this problem. Question says how many grams of nitrogen? So I'm gonna write this information here. How many grams nitrogen question mark, and we need to use that one to make 2.91 kilojoules. So 2.91 kilojoules. So I have to start with 2.91. So I'm gonna write it here, 2.91 kilojoules multiplied by, I should write kilojoules here, and please look here, this is the kilojoule and I'm gonna plug in here. But always when we have energy, we are able to convert that one to moles in the reaction. So I'm gonna write moles. Again, for nitrogen we are looking for. I'm gonna write moles nitrogen. Please understand, we need to use the balanced chemical equation. I'm gonna write that one, balanced equation. 183, and let me write positive, and we have only 1 mole nitrogen. If we don't write any number, it means we imply that one. So kilojoules and kilojoules cancel out. So we are going to write the second conversion factor, moles nitrogen, and I'm gonna convert that one to grams nitrogen. So mole and mass, we need to use molar mass. So if you calculate 28.02 grams is coming from the periodic table. From the periodic table. Moles and moles cancel out. So you can easily calculate amount of nitrogen in grams. So, but I wanted to show you if we are going to work on conversion factors. The conversion factor is used for converting moles to kilojoules, moles to amount of energy, is going to be based on the balanced chemical equation. is going to be based on the balanced chemical equation. Right now, the final answer, I'm gonna report that one as 3 sig figs because our original number has 3 sig figs. So let me write the final answer by this color here. 0.446 grams nitrogen. Grams nitrogen. I solved a couple examples in this video and I reviewed definition of endo-exothermic reaction. I already talked about sign of delta H and hope this video helps you to have better understanding regarding this concept. Thank you for watching this video as well.